Nick, can you fix the heat in here real quick? Thanks. All right, 5-3. We're going to learn the sum and difference identities today. And if you look at this, you think, okay, sine of two angles added together. Sine of u plus v. Sine of 30 plus 45. Sine of whatever. You wish that you could just go sine u plus sine v like it's the distributive property. You wish. That doesn't work that way. Here's what it is. If you want to find the sine of two angles added together, what you're going to do is this. You're going to do sine u cosine v plus cosine u sine v. Some of you guys don't like u and v. It's what the book uses, so I just kind of stick with that. Some of your u's and v's look the same, but those are different angles, okay? So sine u cosine v plus cosine u sine v. All right, now the minus, if you get the plus down, the minus is pretty easy because it's exactly the same, but just with a minus in the middle. Minus cosine u sine v. And all these formulas that we're going to use today, they're called the sum and difference formulas. We are going to prove identity. We're going to use them in identities to prove things. We're going to use them to do solving equations. We're going to use them for all kinds of stuff. Okay. Now the next one, cosine u plus v, is cosine u cosine v minus sine u sine v.
Is this the cheer?
It is. We're going to cheer it out today. And then cosine of u minus v is cosine u cosine v plus sine u sine v. All right, go ahead and write those down. And then you're probably sitting there going, how am I going to memorize all this? Well, there's a cheer to help you out. And it's very helpful. And is it annoying? Yes, it is. But if you know this one and you know this one, then you'll know the other ones because they're just the opposite in the middle, okay? So here's what we do. Here's the cheer. So if you have a sine of u plus v, we do this. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. You remember it? All right. So let me show you what I'm doing. We're doing this. Sine, cosine, cosine, sine. That's for the sine one. And then you do cosine, cosine, sine, sine, sine. And someone's like, well, why do you have three sines? Well, that's kind of sine as in the sign changes, S-I-G-N instead of S-I-N-E. Okay? So say it with me. Are you ready? Here we go. We're going to start right here with this underlined yellow. So we're going to go sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And then you'll have it. You didn't say it. All right, so we're going to do it again. A little bit louder this time. Here we go. You ready? Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Nice. Yes. And you can even ask any calculus kid, what's the trig cheer? They'll tell it to you, but they don't remember what it's for. It's true. Like everyone knows the cheer, but it's for the sum and difference of angles. Okay? And you're going to use it. The next test you take, you'll be sitting there, sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And you'll use it.
How we say it?
I haven't. Is it good?
Very like this.
Oh. Well, Mrs. Pfeiffer gets into it. She does this whole like routine, but I got cut from the cheer squad, so I'm not about to relive that. Okay, here we go. Tangent of u plus v is equal to. Now, these you do not have to memorize, okay? So as far as memorizing goes, you need to know these four. If you know the cheer will tell you two of them. The other two are just going to be the opposite signs of the ones that you know. So tangent of u plus v is tan u plus tan v over 1 minus tan u tan v. Pretty bad, huh? Yeah, those are not fun. And then the tangent of u minus v is exactly the same, just the signs are switched. So it would be tan, ooh, I didn't even write tan right, did I? I wrote tau. That should be tan u. Sorry. Tan u minus tan v over 1 plus tan u tan v. Okay? By the way, also, tan u plus v is also the same thing as sine of u plus v over cosine of u plus v. Okay, because tangent is sine over cosine, doesn't matter what angle it is. So this is also equal to that.
Will you give us that sine part too?
Which part? This?
Yeah.
No. Nope.
Oh, we
So
don't want to use that though, right?
you might. Like if they ask you to find the sine of u plus v, and then they ask you to find the cosine of u plus v, and then they ask you to find the tangent of those same angles, why not just take the two answers that you got and just divide them instead of using this huge formula? But sometimes they don't. They just go straight to find tangent, and then you use that formula. All right, so how are we going to do this? This is what we're going to do. Letter B, we're going to find some uses for these, and here's our first use. We want to find the exact value of the cosine of 75 degrees. So we can go to our calculator, we can punch it in, cosine 75 degrees, it gives us this ugly decimal, but I want to find the exact value. Exact value is going to be in terms of its radicals, okay? 75 is not one of our 30, 60, 90 triangle. So what we do is we break this up. The cosine of 75 is to find the cosine of 45 plus 30. You break it up into angles that you know. Okay? I know the cosine of 45 and I know the cosine of 30, so let's go ahead and do this. You can't just distribute though, you have to use the cheer. Okay? So cosine. So this would be cosine, cosine, sine, sine, sine. So we're going to go cosine 45, cosine 30, cosine, cosine, sine, sine, sine. Change the sign. It's that sign. Minus sine 45, sine 30. Okay, and now we get to evaluate all of these. Are you pretty good at evaluating these now with your unit circle? What is the cosine of 45 degrees in radians? Or, I'm sorry, 45 degrees is not in radians. Pi over 4. Cosine of 45 is rad 2 over 2. Perfect. And then what's the cosine of 30? Cosine of 30, that's right there, so that would be rad 3 over 2. Minus, what's the sine of 45 degrees, or pi over 4? Rad 2 over 2. And the sine of 30 is 1/2. All right, let's go ahead and simplify this. We get rad 2 times rad 3 is rad 6. 2 times 2 is 4. Rad 2 times 1 is rad 2. 2 times 2 is also 4. And so our exact answer is rad 6 minus rad 2 all over 4. That is the cosine of 75 degrees.
You can't like subtract those?
No, they are not like radicals. Like radicals have to have the same radicand, which is the number inside, and the same root, which is, they're both radicals, they're both root 2, but 6 and 2 are not the same. And that's it. And if you wanted to check your answer, you could. You could get your calculator out and make sure that you're in degree mode for this.
So this will be on the calculator portion, right?
Yeah, I'll let you use your calculator on this. So you could check it, cosine 75, and then what I would do is I would go rad 6 minus rad 2 all over 4. Ah, same number. Yeah, and then you smile because you got one right. That's exciting. Okay, let's go on to the next one. Number 2. We're going to find the exact value of the sine of pi over 12. Now, pi over 12, what I would do is I would tell you on the side here that pi over 12 is equal to pi over 3 minus pi over 4. Okay? Pi over 12 is a really small angle. It's 1/12 of a pi. But it's taking pi over 3 and subtracting pi over 4, and that would be pi over 12. But, you know, getting a common denominator here and doing all that, that would be really hard to figure out. So I would let you know that. All right, so let's find it. Here we go. We're going to find the sine of pi over 3 minus pi over 4. So this is our difference formula for sine, so we're going to cheer it out. So this one starts with sine. Sine, cosine, cosine, sine. So sine pi over 3, cosine pi over 4. Sine, cosine. There's a minus in the middle, so it's going to be minus. Cosine, sine. Cosine pi over 3, sine pi over 4. There we go. So sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. It's starting to get in there, isn't it? Mm-hmm. Yeah, you'll be cheering it tonight after you say your prayers. All right, here we go. So what is the sine of pi over 3? Well, you need that unit circle again. And the sine of pi over 3 would be rad 3 over 2. Cosine of pi over 4 is rad 2 over 2. The funny thing is you're going to get like the same answers over and over for these, like with a plus or a minus in the middle. And then the cosine of pi over 3 is 1/2. And the sine of pi over 4 is rad 2 over 2. So you take each of them and evaluate them. And now we get, our answer would be rad 6 minus rad 2 all over 4. Same answer. That's interesting. It's not interesting. It's not. We found the cosine of 75. And this is to find the sine of 15. And of course, they're going to be the same answers, right? All right. Let's move on. Now, tangent. I threw one of these in there for you. They're pretty bad. I'm not going to make you rationalize, so it's not as bad as you think it might be. So we're going to find the tangent of 15 degrees. So we're really finding the tangent of 45 minus 30. 45 minus 30. If you don't like that, if you don't like degrees, you could say it's the tangent of pi over 4 minus pi over 6. That might help some of you know what tangent is. All right, so here we go. We're going to use our tangent formula. Yeah?
Why can't you do tan 60 minus 45?
Ooh, you could. Would you rather do that?
Oh, no, I'm just wondering if you could, like, switch.
Yep, and then they're going to end up the same. Ooh, I love that you said that. Really good. Okay, so here we go. We're going to go tangent of 45, tangent u minus tangent v. So tan 45 minus tan 30 over 1 minus tan 45 times tan 30. There you go. What's that? Plus. Thank you. Oopsie-oos. You're not writing any of this down? No iPad? No. Okay.
Why is it plus?
It's a formula. So it's right here. So if it's tangent of u minus v, it's minus up top, plus on the bottom. Okay, let's evaluate this. What's the tangent of 45? You should know that one very quickly. 1. Right? That's the one that you should know. That's the easy one. It's rad 2 over 2 divided by rad 2 over 2. What's the tangent of 30? Now remember, tangent of 30 is really tangent of pi over 6. It's rad 3 over 3. Remember? Over 1 plus tangent of 45 is 1, and tangent of 30 is rad 3 over 3. Now, the only thing I do make you do on this, because I'm not going to accept that as an answer, that's really gross, I would need you to multiply this top and bottom by 3. Because now you have, not only do you have radicals in the denominator, you have fractions over fractions, and that's just too much, like breaking all the rules. All right, so you get 3 minus rad 3. So you go like this. And then you get 3 plus rad 3. You don't start canceling out things. You can't, okay? This is a minus in here. It's a plus in here. I would accept that as the final answer. I used to not. I used to make you rationalize this by multiplying top and bottom by 3 minus rad 3, which is the conjugate, FOIL everything out. It's just kind of a waste of time. That's fine. That's an exact answer for cosine, or for tangent of 15. All right, should we move on? Number 4. Okay, find the exact value of sine 42 cosine 12 minus cosine 42 sine 12. Now this looks terrible, right? It looks super hard. It's actually really, this one's the easiest one. Take a look. Do you see it? Sine, cosine, cosine, sine. Let's go the other way. All right, so it's already all the way out. Let's bring it back to what it was before someone, took this whole thing and put it all the way out. So this is really the sine of what? 30. It's the sine of 42 minus 12. Do you see that? It's the difference formula for sine. Sine, cosine, cosine, sine. And so this is the sine of 30 degrees. And the sine of 30 degrees is what? 1/2.
You can do that?
Yeah. Yep. This is just the difference formula all the way out. You can bring it back. You can go back both ways. Here you go. All right. You ready for the next page? All right. It's next page. What else is this equal to? Yes. It's equal to sine of u plus v over cosine of u plus v. And cosine and sine, those. Here we go. All right, these are my favorite ones. I love these so much. They're so good. All right, it says find the exact value of the sine of u plus v given that the sine of u is 4/5 and the cosine of v is negative 12/13. And this right here, this pi over 2 to pi, that tells you what quadrant you're in. So where are you if you're from pi over 2 to pi? You're in quadrant 2. Very good. All right, so let's go over to quadrant 2. And let's draw a triangle. Oh, I'm sorry. That's for this right here. That's for angle V. U, though, is from 0 to pi over 2. So there's two angles going on. There's angle U and there's angle V. So let's draw a triangle first for angle U. So here's angle U. They tell me that it's in quadrant 1. So the sine of U is 4/5. That means that opposite is 4. Hypotenuse is 5, and then what would the adjacent side be? 3. Yes, that's very fast. Good job. It's the old 3, 4, 5 triangle. Okay, now the other one, angle V, is over here in quadrant 3. Or 2. Wow, I'm a little off today. Must have been a long weekend. All right, cosine V is negative 12 over 13. So the adjacent side is negative 12. The hypotenuse is 13. Does anyone know this one? 4? I don't think so. 5. It's the old 5, 12, 13 triangle. Yeah. You didn't know that one? Everyone knows 3, 4, 5. A lot of people forget the 5, 12, 13. Okay, so now we're ready. We set it all up. They told me what quadrants we're in. I drew my triangles. Now we need to find the exact value of the sine of u plus v. Well, the sine of u plus v is equal to, we got to do our cheer, okay? So the sine of u plus v is sine u, sine, cosine, cosine, sine. Sine u, cosine v, plus sine, cosine, cosine u, sine v. And now let's figure out what all of these things are. So what is the sine of u? Well, that one we were already given. The sine of u is what? 4/5. What's the cosine of v? Cosine of v, we were given that one too. Cosine of v, negative 12/13. Plus, what's the cosine of u? Cosine of u is, we weren't given that, and that's why we set up a triangle. So we can go to angle u and find the cosine of that. What is the cosine of angle u? 3/5. Very good. It's adjacent over hypotenuse. This is all right triangle trig. Times the sine of v, 5/13. Perfect. Okay, I'm going to need a fraction answer. Your calculator can handle this, though. This is also why I give you your calculator. I wouldn't make you do this whole thing by hand. So in your calculator, you would do 4 divided by 5 for 4/5 times negative 12/13 plus 3/5 times 5/13. Enter math fraction, and you get negative 33 over 65. Okay? On your next test, you're going to have one like this, and I will say only fraction answers will work. All right, so we finished the uses, And now we need to prove the identities. Yay. All right, so here we're going to prove, and then solve. So these are identities coming up, okay? Remember, you cannot cross the equal sign. You have to show one side equals the other side. So here we go. Number 6. I gave this identity to you. This is one of our cofunction identities. I gave this to you on the first day, and I told you it was true. Now we're going to prove it today. Okay? This is the cosine of u minus v. It's the cosine of a subtraction of two angles. So let's go ahead and write the whole thing out, cosine of u minus v. Cosine, cosine, sine, sine, sine. Okay? So cosine pi over 2, cosine x, cosine, cosine, sine, sine, sine. Change the sign. Sine pi over 2, cosine x. No, that should be a sine. Sine x. So cosine, cosine, sine, sine, sine. And we're trying to get this equal to sine of x. All right, so let's go ahead and figure this out. There's some things we can do here. We know what the cosine of pi over 2 is. If you go to your unit circle and you go to pi over 2, this is the point 0, 1. So what's cosine of pi over 2? 0. 0 times cosine x plus, what's the sine of pi over 2? 1 times sine over x. Do you see it? 0 times cosine x is 0. 1 times sine is sine x. So we get sine x equals sine x. Kind of an easy little proof, especially compared to the ones you did on your quiz Friday.
Really?
Yeah.
What about that? Oh, just times one.
Yep, times. Kind of nice, huh? Not too bad. All right, let's go to number 7. We're going to prove that the sine of x plus pi is equal to negative sine of x. If you think about it, think about the graph. Sine of x plus pi is going to be a shift of pi to the left. It's going to equal just the negative sine x. That's cool. We're going to prove it. You're like, can I just graph them both and show they're equal? No, that would be pretty nice, though. All right, let's do the cheer. Are you ready? Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Isn't it fun? All right. Sine x, cosine pi, sine cosine, plus cosine x, sine pi. And we're supposed to get that equal to negative sine x. All right, so do you see these? Now you can't evaluate sine of x because x is a variable. But once you have cosine of pi and sine of pi, you can evaluate those on your unit circle, right? So this becomes sine of x times, what is the cosine of pi? Well, go to your unit circle, go over here to pi. This is the point negative 1, 0. So what is the cosine of pi? Negative 1. Plus cosine x, and what's the sine of pi? What's the y value there at pi? 0. And so guess what? You're there already. You get negative sine x is equal to negative sine x. Not too bad, huh? All right, 2 more. 2 more. Oh, this one's really fun. Let's do it. Here we go. We're going to prove that the tangent of theta minus 3 pi over 2 is equal to negative cotangent. All right, so let's use our tangent formula. Here we go. It's tangent of theta. You might memorize this. I mean, it's not that bad to memorize. I'll give you this one because you guys have a lot to memorize. But here we go. Tangent of theta minus tangent of 3 pi over 2 over 1 plus tangent theta times the tangent of 3 pi over 2. Okay, it looks like a big jumbled mess right now, but we can go and evaluate what the tangent of 3 pi over 2 is. So let's go to 3 pi over 2, which is down here, and this is the point 0, negative 1. Is it undefined there? It is. We can't do it this way. Right? Y over x?
Insolvable.
Ugh, no, it's not, though. So, I'm glad I did that. I couldn't do it that way. I couldn't solve tangent of 3 pi over 2 because that's undefined. So I'm going to have to figure out a different way to solve it. Any suggestions? Look back at your notes. Look back at that first. Don't have any restrictions on what they can and can't be. So we'll have to do it that way. All right. So we're going to do sine of theta minus 3 pi over 2 over cosine of theta minus 3 pi over 2. And we're going to have to do the cheer twice. Well, each cheer once, really. All right, so let's take a look at the top. We have sine of theta of u minus v. So that's sine, cosine, cosine, sine. So sine, cosine, minus cosine, sine. Okay, that's just the numerator. Did I lose anybody on that part? We're okay? So it's the sine of theta minus 3 pi over 2 is sine, cosine, cosine, sine, over the bottom, cosine, cosine, sine, sine, sine. So cosine, cosine, change the sign, sine theta, sine 3 pi over 2. Now, that looks like a huge mess, doesn't it? It's pretty bad. But it's all going to turn out pretty good. Yeah. So let's look at this right here. Cosine of 3 pi over 2. What is the cosine of 3 pi over 2? Cosine of 3 pi over 2 is what? Yeah, right here. It's 0. And then the sine of 3 pi over 2 is -1. So let's go ahead and replace all those with those things. All of those means this and this and this. All right, so I have sine of theta times 0 minus cosine theta times -1 over cosine theta times 0 plus sine theta times -1. Okay, so our numerator becomes cosine theta, because this is just 0 and that's 0, and we get a negative times a negative is positive, and this is negative sine, and what is cosine theta over negative sine theta? Yes, negative cotangent. Woo! We did it. Okay? And I didn't do that first part on purpose. I really thought it was going to work using that tangent formula. It didn't, so I had to, improvise and do something else. And I saw that other formula and went with it. All right, last one. Number 9. It's a lot for a Tuesday after a long break, sorry. All right, so this one, we have to solve this, okay? No, this is not an identity. It does not work for every x value. We need to find out which x values it does work for. So we're going to solve this equation, and the way that you solve it is you have the sine of x plus pi over 4 plus the sine of x minus pi over 4. We're going to do the sum and difference formulas one each time, okay? So here we go. First of all, we're going to start with this right here. Sine of x plus pi over 4 is sine, cosine, cosine, sine. So sine x cosine pi over 4 plus cosine x sine pi over 4. Okay, that's just this part right here. Plus, now we'll do this part. So plus sine x minus pi over 4. So sine cosine minus cosine sine. Wow, that's a long string. And this is equal to -1. So let me let you get caught up to there. So all I did was I just expanded everything, okay? It's kind of like if you were going to solve something that had a squared in it, you'd have to FOIL the whole thing out and do it that way. This I have to expand using my sum and difference formulas for sine. All right, now, do you see anything? We've got some like terms here, so this is exciting. I've got a positive cosine x sine pi over 4 and a minus cosine x sine pi over 4, so those cancel out. Don't you love it when things start canceling? Love it. Then I have a sine x cosine 4 plus another sine x cosine 4. So how many of those do I have? 2 of them. 2 sine x cosine pi over 4. All right, I'm getting there. Now, do you see that cosine of pi over 4? Yeah, we can evaluate that. That's a number. So 2 times sine x, and what is the cosine of pi over 4? This is the one you know. Yep, rad 2 over 2. Okay, and then those can cancel out, or reduce, I should say reduce on that. And then we end up getting sine x times rad 2 is rad 2 sine x equals -1. Okay, we're solving, so we're now allowed to go across that equals sign, divide by rad 2. Sine x is -1 over rad 2. And now we have to find, and by the way, whenever you're solving, we're always on the interval from 0 to 2 pi. Okay, even if the book doesn't say that, we are in here. We're always on the interval 0 to 2 pi. So I need to find out what angles give me -1 over rad 2. Now you may not recognize that, but if you went ahead and rationalized, you would see that sine x is negative rad 2 over 2. You recognize that on your unit circle. So which angles from 0 to 2 pi going around the unit circle, which angles give me negative rad 2 over 2? Well, yeah, not quadrant 1, not quadrant 2. So over here and over here. So 5 pi over 4, I heard someone say. And 7 pi over 4. Very good. And those are your 2 answers to this problem.